All right, so in section 5.2, we're going to learn about matrix multiplication. So here, we want to multiply matrices. We've already learned how to add them, subtract them, multiply them by scalar multiples, but now what we want to do is we want to take two matrices and multiply them together. Okay, so that's our goal. Now, let's start out with the definition. We always do, most of the time. The product, A times B of a row matrix A and a column matrix B is a 1 by 1 matrix. It's not the absolute value. This is a 1 by 1 matrix. Okay? To multiply matrices, the length of the row in A must match the length of the column in B. So what that means is if we have an N by M matrix and M by P matrix, these two, the rows or the columns here have to match the rows here in order for us to multiply it. That's what that's saying. Okay? That's what that's saying. Now, here, after we do that, multiply each entry in A, going from left to right, by the corresponding entry in B, going from top to bottom. And then we'll add the results. Okay? So, what I want you to do is pay attention, and then I'll give you time to write. So, we have this, what size matrix here? 1 by 3. I'll write it on the top of the matrix so it won't get in the way. So 1 by 3 matrix here. Then we have what size matrix here?
3 by 1.
A 3 by 1. So our result should be a 1 by 1 because these match up. Those match up. So our resulting matrix should be a 1 by 1. So it says here that this has to match this, which it does. Then it says multiply from left to right and top to bottom. So we're going to multiply 4 times negative 4. Four times negative 4. We're going to add to that 0 times 1. And then we're going to add to that, guess what? 1 times 8. You got it. 1 times 8. And so we have negative 16 plus 0 plus 8, which gives us what? Negative 8. So we have the 1 by 1 matrix, negative 8. All right. Oh, sorry. Your question. Example 2, we want to compute the product for this row matrix by this size 2 by 4 matrix. So, is that possible?
Yes.
Yes, it is possible. Yes, it is possible. Because we have a 1 by 2 matrix, and we're multiplying that by a 2 by 4 matrix. What should be the size of the resulting matrix? Right, the resulting matrix, and right now we're just talking about sizes. Resulting matrix should have size 1 by 4. Very good. So, remember, in order to do that, we multiply left to right, top to bottom for the respective entry. So I wish I had 2 highlighters here, because what you're doing is you're multiplying this times this entry times this entry plus this entry times that one. That's going to give you this one entry. So, if you want to, pay attention and then write. I'll give you time to write. So this would be 2 times negative 3. So this one times that one plus this one times this one. So plus negative 1 times 4. That's going to give us the first entry. So typically we wouldn't write a bar to indicate it's something else, but I'm going to do it just to let you know we're separating entries. Typically you would not do this. I don't recommend doing it. So what would be the next one? So we multiplied the first row by the first column here.
So you do 2 times 1 and then negative 1 times 0?
But what goes in between then? You said and then. So you have 2 times 1 and then you said and then negative 1 times 0. What do you mean goes in between the and then? Plus.
Yeah,
Good. Plus. Good. So 2 times 1 plus negative 1 times 0. Good. What's the next one? Plus negative 1 times 1. Good. So you're multiplying the first row by the third column, and then what's your last one?
2 times 3 plus negative 1 times 0.
Good. So then we simplify. So you have negative 6 minus 4. Then you'll have 2 plus what? Negative 1 times 0 is? 0. And then we'll have 8 minus 1. And then we'll have what? Good. And I dropped those bars because typically, like I said, you don't write them. So then you'd have negative 6 minus 4 is negative 10. Then you'd have 2. Then you'd have what? And then, good. Notice that you have 1 row, 4 columns. 4 columns. So it is what it should be. That's your answer. What questions do you have? Together. So, example 3, you have a what size matrix?
2 by 3.
And a,
3 by 2.
can you multiply them? Yes. So you have a 2 by 3 matrix here, and you have a 3 by 2 matrix here. Notice that the columns there match the rows here, so we can multiply. Our resulting matrix should have what size? 2 by 2 should be the resulting size, or should be the size of the resulting matrix. Now, in general, let me just write something down. In general, a 2 by 2 matrix has A11, A12, A21, A22. That's what a general 2 by 2 matrix looks like. This means first row, what?
First column.
First column. This means?
First row, second column.
This means?
Second row, first column.
And?
Second row, second column.
Good. Second row, second column. Second row, first column. You can use that to help guide you here. So you know to find A11, you need to multiply the first row by the first column. Then to find the other one, you need A12, you multiply the first row by the second column. Find A21, you multiply what?
Second row.
By the first column.
That's right. And then to find A22, you multiply
Second row
by the second column. That guides you. You can use your subscripts to help you. Okay? So, we'll write it out. So we will have a 2 by 2 matrix. So you would have 0 times 1. I might have to erase that last one. So you'll have 0 times 1. We're multiplying this times this. Then you have plus 1 times 4 plus that's good. Negative 1 times 0. What's your 1, 2 entry going to be?
0 times 1.
Good. So this one times this one. Go ahead.
Plus
Mm-hmm.
1 times 2.
1 times 2. Good.
Plus negative 1 times 1.
Negative 1 times 1. All right. Good. What is the 2, 1 entry? 3 times times 1 plus, good, plus 1 times 4 plus negative 1 times 0. You got it. And then the 2 entry is going to be what? 3 times 1 plus 1 times 2. That's a 1. What is that? 2. Plus negative 1 times 1. And then we simplify. So we get 0 plus 4 plus 0. Then we have 0 plus 2 minus 1. Then we have 3 plus 4 plus 0. Then we have 3 plus 2 minus 1. The 1, 1 entry gives us 4. The 1, 2 entry gives us 1. The 1 entry gives us 7. And the 2, 2 entry gives us what?
6.
Nope. 3 plus 2 minus 1.
5.
3 plus 2 is?
3 plus 2 minus 1 side 4.
Good, 4. So this is your answer here. And this is how you multiply matrices. All right, so a few observations. In matrix multiplication, we take rows on the left times the columns on the right, okay? So the number of columns of the matrix on the left must match the number of rows of the matrix on the right. For example, a 1 by 6 matrix, in order to multiply this by something times 2, in order to multiply it, since these are 6 columns, we have to have 6 rows. So this needs to be a 6 by 2. And then the resulting matrix should be a 1 by 2. Should be a 1 by 2. Okay? Definition. If A is an M by N matrix and B is an N by K matrix, then the product A times B is the M by K matrix, whose ijth entry is the product here. This may seem like, what the heck are we doing? However, remember, it's the same concept as we've talked about already. This is just putting a general definition to it. Okay, so it works for all things. So you have AB, so by J, you have the ith row here, and then you have the B1J. So you have this. Notice that you multiply A1J. So we're finding the ijth entry of the ABth product. Finding the ijth entry of the product AB, that matrix. So you multiply the ith row times the jth column. That means you multiply AI1 times B1J plus AI2 times B2J plus AI3 times B3J plus everything out to AIN times BNJ. Okay, so that gives us the general definition of what we've already discussed. Now, something to note is that in general, matrix multiplication is not commutative. So that means A times B in general is not equal to B times A. Okay, so suppose we have the 2 by 2 matrix whose entries are 1, negative 1, 0, 2, and suppose we have the 2 by 2 matrix B whose entries are 3, 0, and 5, negative 1. Let's find the product A times B. Well, let's write them beside each other. We have 1, negative 1, 0, and 2. And then we have 3, 0, 5, negative 1. They're both size 2 by 2. The number of columns here matches the number of rows here, so we can multiply the matrices. So we're going to get a 2 by 2 matrix ending. So remember, we want a 1, 1, so first row, first column. 1 times 3 plus negative 1 times 5. Okay, then we have the 1, 2 entry. So what I'm thinking of and I have in the back of my mind, I have this 2 by 2 matrix, the general one, that's telling me what row, what column to use. So first row, second column. So 1 times 0 plus -1 times -1. So we'll have 1 times 0 plus -1 times -1. Then we want the 2, 1 entry here. So second row, first column, 0 times 3 plus 2 times 5. So 0 times 3 plus 2 times 5. There's no particular reason why I didn't write parentheses there, so let's do that. Then we have second row, second column, so 0 times 0 plus 2 times -1. And simplifying that matrix, we get 3 minus 5 is -2. Then we have 0 plus 1 is 1. Then we have 0 plus 10 is 10. And then we have 0 plus a -2 gives us a -2. Okay, so that is equal to the product A times B. But now, let's find B times A. So we'll have 3, 0, 5, -1. And then we'll have A is 1, -1, 0, 2. Okay, and now we want multiply them. So first row times first column, 3 times 0. So 3 times first row, first column, 3 times 1 plus 0 times 0. Then in our 1, 2 entry, so over here we're going to have first row, second column, 3 times -1 plus 0 times 2. So 3 times -1 plus 0 times 2. And then our 2, 1 entry, second row, first column, 5 times 1 plus -1 times 0. So 5 times 1 plus -1 times 0. And then second row, second column, so 5 times -1 plus -1 times 2. So 5 times -1 plus -1 times 2. We simplify that. 0 plus 0 is 0. You already see that the 1, 1 entry doesn't match this one. Okay? Now, -3 plus 0 is -3. 5 plus 0 is 5. And then we have -5 minus 2 is -7. So notice that A times B, which we got here, does not equal B times A. So they're not equal. Okay? All right, so in general, matrix multiplication is not commutative. A matrix where the number of rows is the same as the number of columns is called a square matrix. It's called a square matrix. So example of a square matrix is a 2 by 2. The number of rows matches the number of columns. Another example is a 3 by 3, 4 by 4, and so on. Okay? Now, the last definition here, the n by n identity matrix, that's an n, identity matrix, I, is the matrix with ones down the main diagonal. The diagonal starting at the top left and zeros everywhere else. Okay? So notice that I sub ij is equal to 1, and we have that I sub ij is equal to 0. So for example, the identity matrix would look, the 3 by 3 identity matrix would look like 1 0 0 0 1 0 0 0 1. So we have ones along the main diagonal and zeros everywhere else. Okay? So I wrote that on the previous page because I wanted you to be able to see it there. But just for filling in your notes, note that here, the 3x3 identity matrix is 1, 0, 0, 0, 1, 0, 0, 0, 1. Okay? Now, more properties of matrix multiplication and transposition. A times B times C is the same thing as A times B times C. A scalar C times AB is equal to the scalar multiple A, C times A times B. If you have two scalars, C and D, C times DA is the same thing as C times D times A. A times the identity matrix is the identity matrix times A, and that's equal to the matrix A. A times B plus C is equal to A times B plus A times C. A plus B times C is the same thing as A times C plus B times C. And the zero matrix times A is equal to A times the zero matrix. That is equal to the zero matrix. A times B transpose. Notice, if you take the transpose of the product AB, it reverses the order. So you have B transpose times A transpose. This is where students make a lot of mistakes, so make sure you understand that AB transpose is equal to B transpose times A transpose. Notice that the order is crucial here. Okay? So, let's translate. Let's do one more example. We're going to translate the given matrix equations into systems of linear equations. And this is using what we've learned about matrices. This is a 2x4 matrix. This is a 4x1 matrix. So we should have a this is a 2x4. This is a 4x1. So we should have a 2x1 result. Okay? Which is the same thing as this 2x1 matrix over there, right? So, first row, first column, 0 times x plus 1 times y plus 6 times z plus 1 times w. So that would give us 0x plus 1y plus 6z plus 1w. And since they have the same size, that means the entries have to be the same. So that's equal to -2. Then we have 1 times x, -5 times y, 0 times z, 0 times w, and we're adding all of those, and it's going to be equal to 9. So we have 1 times x plus -5 times y plus 0z plus 0w. And that's equal to 9. So that gives us y plus 6z. So we have y plus 6z plus w is equal to -2. And we have x minus 5y is equal to 9. That is our system of linear equations. Okay? All right. Have a good one. This is matrix multiplication.